Okay, so quick time has started, and let's go over questions that you had on your homework, because there's just little intricacies that we need to go over. And let me answer Kate's question that today I probably will take a little time to if you already have questions and you've looked at the review, I probably will take a little time to do that. Did I give you Delta Math assignments also?
Yeah, for finals.
Okay, there's like, I think, a big group that's a final. And I'll get you just a second, Ava. Thursday, Monday, and Wednesday will be review. Bring your review packet with you, be ready with questions. If it could be that I'll weave some of the new material that I want to put on the exam into that, but I'm not going to be adamant about it. I'm going to be adamant on those 3 days about the review. And then if we've gone over all the questions that you want, I might introduce something that's, fairly, that you can handle. We may learn something new today. We'll see how it goes. But I'm not, I'll reserve those 3 days for review. Okay, question, Ava.
Oh, it's just about if we're gonna know that we're gonna know what on this packet is on the test.
If there's
by the end of this week,
anything
so we
that
can do
is,
it.
yes, you'll know by the end of the week. Okay. So it may be after class on Thursday that I send out an email if there's anything to omit from the packet. Okay. But right now you can be studying all the things you know that will be on it. Okay. Dakota.
Can we do number 42?
Yes, we'll start with 42. Do you have a different question besides a number, Brent?
Oh, no, I have a number.
A number?
Sorry. I have a question besides a number.
Okay.
If there's some stuff that you omit and we see some stuff that we feel as if we haven't covered, can we talk to you about that on a class on Thursday or Monday, I think? So we can either go over that or then you will be we didn't have
Yeah, that's what Ava
No, I
was
know, but
asking.
if it's something that you miss and it's still there and we're still
You
we
can
don't know
always
how to
ask
do
me
this.
about that.
Okay.
Yeah, you can always go, what about number 33? And I might go, oh my gosh.
Okay.
Yeah. Right now, I don't plan to omit anything from it because I made it out with my syllabus already planned. And I haven't changed my syllabus. But we'll see what happens, okay?
Oh,
Alright,
what's happening with the flashcard? Sorry.
I have asked and asked. I don't have an opinion on the flashcards myself, but they do. A couple of people in the math department do. And so today I'm like, so what about flashcards? And they're like, we're going to meet about that on Friday. So hopefully
They didn't
they
make
go.
it such a big deal out of it.
I know. So I'm not caught up in that, but I can't tell you what they want you to have and not have. I would say we definitely won't put your 1, 2, 3 chart kind of stuff on there, but I would think you could put your identities on there. Some people, I think, are way against putting examples on there. I don't. Some students seem to think examples are all that, but I don't think they are. But anyway, I think they're going to say no examples, but just
You have so many types of questions.
I know.
How would you do it?
Okay, whose am I answering right now? Dakota?
I said question 42.
42. What page?
373.
Thank you. All right, 373, number 42. Getting there. All right, great question. 2 sine squared x equals 2 plus cosine x. So we have 2 sine squared x. Let me make sure I
Equals
copy it.
2
Plus cosine x. Thanks. Okay. First thing I see, Dakota, is I don't want sines and cosines in there. I want it all the same word. So I'm going to use an identity, and I change the squared ones. All right, so sine squared is 1 minus cosine squared. Now I'm going to be able to, I think I sent a video about factoring, and there's some really good examples in the book also, okay? So are you okay with that, Dakota?
Yeah.
So now I'm going to distribute 2 minus 2 cosine squared x equals 2 plus cosine x. And this is what you would call in Algebra 2 a quadratic. And so I'm getting it in the form of, I want it to look sort of like x squared minus 7x plus 4 kind of thing that I would maybe factor. I like for my lead coefficient, my squared coefficient to be positive. So I decided to move everything over to this side and start with 2 cosine squared x. I'm going to put cosine x in the middle. And I think my 2's on this one cancel out. Okay. So I'm going to factor. Okay. I'm sorry, Kate, the ninth graders that I teach actually might walk up here in the hall and say, what's the first rule of factoring? So I'm trying to designate a ninth grader to carry on the mantle that you've been carrying so well. What's the first rule of factoring?
So yeah, wasn't that
And it's a funny joke between us since algebra, but it's really, really important because you'll drive yourself crazy trying to do some factoring if you haven't already taken out what's in common, and I see people forget it all the time. And they're trying to do this big factoring thing and they don't have to. So these have a cosine in common. We should all back away and see what we can take out. If I take that out, it gives me 2 cosine x plus, and then 1 is holding the place for cosine x. Then you set your factors equal to 0. So that gives me cosine x is equal to 0, and 2 cosine x plus 1 equals 0.
Wait, how did you get
How'd I get what?
that? Like, how are those equal to 0?
That's why you're
Oh.
factoring.
Okay,
You
got it.
factor, and if you factor and it's equal to 0, that means one of your factors has to be 0. Like that can't be 3 times 7. One of these has to actually be 0, or both. And so you're given the possibilities of that. This one's gonna give me 2 cosine x equals -1. And so I have cosine x equals -1/2. Okay? So cosine 0, you need to be good at that, is pi over 2, and 3 pi over 2. Y'all have been a fantastic class about what I call really doing your homework. So you're thinking through this stuff at home. I don't think you're skating over it at all. And it gets easier and easier as you have to unthink these things. The angle that gives me a cosine of -1/2 would be 60-degree angles, so they're going to be pi over 3s. In the second quadrant, 2 pi over 3 and 4 pi over 3. Okay? And so I ended up with 4 answers. And if we put it on Desmos from 0 to 2 pi, we would actually see some loop-de-loop thing that has 4 answers. It's probably pretty interesting graph. Now let me make sure I answer the question. I just double-checked because it said find all the solutions on 0 to 2 pi. And so all I was doing, I was thinking around one cycle. If it said find all solutions, I'd say plus 2 pi k. Okay? Because that's the period of cosine. Alright, now I want to pause and talk about something. Do y'all see this says where does cosine x equal -1/2? If I didn't know that and I was dependent on my calculator and I pushed inverse cosine, it wouldn't give me but one of them. So let me say this real quickly before we move on. There's a couple of things I want to say about this. Sorry. There's a big, big difference if I ask you this and if I ask you this, which is the same thing as this. Okay? If I say where's cosine x equal 1/2, you want to go, you're kidding me, right? Like I got to list all of them? So then I go, okay, well just give me the ones from 0 to 2 pi. That would be pi over 3, or 60 degrees, and 300 degrees, which is 5 pi over 3. Those are the answers from 0 to 2 pi. Because you're actually on this big cosine function, okay? If I ask it like this, you only give me one answer. Just like if I say square root of 25, you only say 5. So the arc cosine is a way to at least give you a reference angle. And you have to know that because that's all your calculator's programmed to do. What quadrants can you look in for inverse cosine? Quadrants what and what? Does anybody remember?
2 and 3.
Never 3.
Is
One
it
and
1 and
two.
2? Sorry. Is it 1 and Wait, yeah, that's my question.
Arc sine and arc tan are 1 and 4.
So why is that equal to 5
Alright,
pi
hang on
over
just a
3?
minute, just a minute, okay? Arc cosine, you look in quadrants 1 and 2. Arc sine and arc tan, did you put it on your memo page? It probably was in a video at some point. So hopefully you actually put it on your memo page, okay? On your memo page, if you don't have this, you should have this. Inverse trig functions, if you have inverse sine or inverse tangent, you're only looking in quadrants 1 and 4. The only way to get into quadrant 4 we talked about is to go down into it. You're not allowed to go around, you'll fall off a cliff, okay? Sorry that's so dramatic, but I don't want you to do it wrong. Arc cosine, there's no reason to go in quadrants 1 and 4 because cosine's positive in both of those. So in arc cosine, we go in quadrants 1 and 2, okay? That should be somewhere on your memo page. And so what happens is, back in the day, even before technology, people needed a way to at least get started on the problem, and so do you see it helps them encounter the first thing that would happen to it. Girls, if you're on an inverse trig function, and somebody has, okay, so let me go back. It depends on how the question is worded. So let's review an example that I give you all the time. There's a difference in this question and this question. They're obviously very similar to each other. On this question, I've got to answer 5 and -5 because I'm on a parabola. In this one, what's the answer?
5.
Just 5 because you're on a half parabola, okay? So if I say cosine x equals 1/2, you're on the big, huge cosine wave where you get lots of answers. If I say arc cosine, I'm like, okay, just hang on a minute. You're pretty much just finding a reference angle, okay? So you can look in quadrants 1 and 2. Wouldn't you encounter your answer in quadrant 1 since it's positive? And so I would only say pi over 3 if someone words the question that way. The reason this has got to be a big deal is this. Suppose you encounter this on the test where you've worked something, you factored it, and you're looking at where cosine is -1/3. Say you've worked it, you factored it, and you have cosine's -1/3, and you don't know it, who are you going to have to ask? Your calculator. So girls, you got to know what's going to happen. When you use your calculator, y'all did this great actually one day just by yourselves before I ever taught it to you. I gave you like a worksheet to answer a bunch of stuff. I don't know if you remember it. And something happened like with the next class and I didn't like follow up on it very well. But, you know, like I gave you a bunch of questions like this to find all the answers to, and y'all were punching in your calculator, but you were realizing there were more than what your calculator was telling you. If I push arc cosine, it's only going to check the first and second quadrant. Why won't it find it in the first quadrant? Alright, so negative is going to force it to go over here. I don't know what the answer is going to be, but it's going to give me some angle in the second quadrant. By the way it's worded though, I got to find all the angles where that happens. So if I do this, let's go ahead and do it.
It's 109.47.
Oh, thanks. 109.47 degrees. But isn't cosine also negative down here?
Yeah.
Which my stupid calculator doesn't know about. So I'm going to take the 109.47 and I'm going to also, okay, let's do this together. Let's reason it out.
Minus 109.47.
You're right,
Then it's
Bren.
plus-
What are you doing?
So I did 180 minus 109.47.
To find her reference angle.
Yes, which is 70.53.
And then you added it to
Added.
180.
Yeah, so then
I
you
got-
get 250.53.
Alright, so let's talk about that. It went into the second quadrant, it found 109. That is one of our answers. But there's another answer down here. So do you see Bren took 180 minus 109 whatever to get her reference angle. Once she knows the reference angle, she can add it to find the one in the third quadrant. To answer, do you see how this is worded? That means find all the answers from 0 to 2 pi, or if I don't say from 0 to 2 pi, you would have these two, plus 360k, where k is any integer. The big deal is it's already coming at you worded as an inverse trig function, you only give one answer. Okay? Alright, so questions just on this. Alright, Anya?
Can you scroll up for a second and
Yeah.
for the thing? What is I just don't understand, since we just went into the third quadrant for cosine, what does it matter that it's just like 1 and 4
If it's
or like 1 and
worded
2?
like this, you're on the inverse function. I just never said arc cosine, I just chose to use it.
Oh no, I mean, if it is arc cosine.
If it's given to you like that, just like if this is given to you like that, if it comes at you like that, you just say 4. If I ask you a question that's already an inverse trig function, then you've got to behave this way. Just like if I say square root of 25, you just got to say 5. but it's way different. What are you gonna do here, Anya?
It's like plus or minus,
Okay,
Like
but I don't know the answer, so what are you gonna have to do?
square it.
You're gonna have to use the square root function. It's only gonna give you one
Yeah.
answer, but because how it's worded, you gotta override that and give me both answers.
Okay,
But what if I just ask it like this?
that's only one answer.
That's what I'm saying. If it's worded like this and somebody says, I'm already on the inverse trig function, it's not that you chose to use it. Somebody's already put you there, you just you behave this way,
Okay,
okay? But do you see it could come a time though, where you're working a problem and you have sine of x is equal to 3/5 and you need the angle.
yeah,
It's only gonna give you one angle because you're using the inverse trig function. I want more if I word it that way.
okay.
Cause I'm on the big sine function there.
So if you're using the like little one or like the inverse one, and you find
Like, see here, I'm gonna choose to use the inverse function, but it doesn't tell me to. Just like this. I don't know what the square root of 27 is. Nobody asked me the square root of 27. They asked me what I squared to get 27. I'm gonna have to grab my calculator and go second x squared. I'm gonna have to use the inverse function. It's gonna give me one answer, but I gotta give more.
if you're using like the inverse of sine, can you, and it's like the chart or like the 1 and 4 chart says where the inverse of tan and sine are positive. So if you get a number, like if you're doing a sine problem, will it be positive in the fourth one, or is that just for tangent? Because they share like the same thing. I don't know if that makes sense.
Let me see, I had a worksheet. I must have given it to y'all. I wouldn't have thrown it away, but it's not in my folder. Let me find it. I'll pull it up. Oh, that was honors. Okay. So that was a test. Didn't really want a test, but we'll work the problems off of their test. Okay. So, what is that? I don't even know what that is. I don't want, can I change it? I don't know what just happened.
That's really pressed over the commands maybe. That's like to take a screenshot or take a screenshot.
Oh, I didn't know you could do a screenshot like that.
I didn't mean to, but like,
The video's still recording, but like that's like
okay.
I thought the screenshot was like fast.
So I don't know where that is. Let me go back.
It's on your desktop.
Really? Julie was gone. I just looked back and I was like, oh, she's not here. And then I was like, wait, never mind, she is.
I was very strong myself.
That
There
would
paper
be-
towels in the
yeah.
bathroom.
Yeah, I know. I had to go to the nurse to get paper towels. It was, I was like walking with my
My paper
hands dripping.
towel machine in the pit doesn't work.
I don't
either.
use that bathroom
It
unit.
sucks.
I use the 4th floor one. The haunted one.
I never use them much.
Okay, so this is what I'm saying.
Oh, is it?
Oh.
Cause no one's over there anyways.
So this is what I'm saying, is, arc cosine is like saying, I'm on an inverse function of some sort. So arc cosine, I'm only gonna answer from quadrants 1 and 2.
Okay.
Somebody said, hello, you're on the inverse function. Arc cosine, I misspelled it, sorry, is only in quadrants 1 and 2. Arc tangent is only from quadrants 1 and 4. Arc tangent is only from quadrants 1 and 4. In fact, that one doesn't even make sense. Did I really put that on the test? Number 4 doesn't even make sense, so we're not going to do number 4.
I was like, oh.
That's kind of scary. Okay.
I got a little nervous.
So here, arc cosine is 1/2. I'm gonna find it in the first quadrant because some of you have realized that because it's positive, okay? So all it's really asking is what's the first thing you think of, which is 60 degrees.
Yeah.
Okay, and so it's kind of cool, like, if you're in the inverse trig function, it's like the first thing that comes to mind, okay? Arc cosine of -1/2, I'm gonna find in the second quadrant. So I'm not gonna find it here, I go over to here and I get 120, okay? Do y'all see with arc sine, that wouldn't have been a very good definition because sine is positive in both of those quadrants. That's why the rules are the way they are. When I come down here, this says tan of 315, which is -1. And then it says arctan of -1. This is a great question. All right, make sure you work the problem from the inside out. These don't just cancel out. The answer is not 315, okay? They sort of cancel out, but they don't just cancel out like this. What's the answer to this problem? Don't we loosely say, oh, a square root gets rid of a square?
Is it 45
3?
degrees?
This one, I'm sorry.
It's negative.
That's 3, isn't it?
Yes.
Okay, because if you work it from the inside out, -3 squared is 9, and square root of 9 is 3. So you've gotta be really careful with inverse functions at this level. All right, so back to this one.
Is it
Go ahead, Nazareth.
is it 45 degrees?
It's not
Negative.
45 because
Negative.
tangent of 315 is -1. And so we're not gonna find it up here. That means we've gotta turn around and go down here. So Brandon's negative 45 degrees. These have one answer, then they have one right answer, one correct answer. Somebody's already mandated what quadrants we're gonna go in. And girls, that's okay, that's not weird. That's like somebody a long time ago mandated that 2 + 1 is 3, and I can't argue that fact anymore, cause it's set. Y'all see what I mean? Okay? And so, somebody had to pick, I don't know who it was, but we all have to do the same thing, or we're not gonna get the same answer. I would count off, listen, I would count off if you said 315. You could argue that that's coterminal, but you've gone over all of this area where you're not allowed to go. You're only allowed to go in the first quadrant and the fourth quadrant. To help you know why someone decided that, do y'all know that's the first tangent that you like to draw? This is from -90 to +90, -90 to +90. There's no reason to keep going forward that way if you cared, okay? If you don't care, that's fine, just memorize it. I do think it helps a little bit to know why. Whether you care or not, at least you have a reason. But ultimately, you just have to do it. So, you'll see why I'm being like, oh my gosh, she's
What's
like,
on those dot lines?
It was
Isn't
like
there a
a
dog?
It's like a design.
I don't know, I hope it's not something inappropriate. I love these. Okay, other homework questions.
Those are really cool. I love this.
Yeah.
Actually, yeah, I have 47.
Oh, sorry, Alex.
Can we do 47?
47, I'm doing
Can we
47.
do 35 after
Because
that?
Yeah.
would that not be the most random thing
Okay,
ever?
47 is 2 secant squared plus tangent squared x minus 3. Now, I haven't worked this one at least in a year. I haven't worked it recently, so in looking at it, there's 2 things that are squared in there. I probably could go either way with it and be okay. I could change tangent to secant squared plus 1 and get it all with secants.
Yeah.
Or I could change secant squared to tangent squared
Minus.
plus 1. I'm sorry, I said that wrong. Okay? I'm going to leave this 2 secant squared the way it is. And I know that tangent squared plus 1 is secant squared. So what is tangent squared? Is secant squared x minus 1 minus 3 equals 0. Let me pause. Are y'all okay with that? So I have 3 secant squareds.
Should we put secant squared
Minus
minus
4.
1 in?
You could put in parentheses if you would really need to, Bran, if it had a coefficient
Okay.
or a minus sign. Okay?
Okay.
So that's not a bad idea because I had a plus sign, it wasn't gonna do anything, but you wanna do whatever for the whole thing.
Okay.
Now I'm gonna, I'm not gonna factor this traditionally, I'm just gonna add 4 and divide by 3, cause I don't have a middle term. Yeah. So this gives me secant squared x equals 4/3. Then I'm gonna square root, now this is what we've been talking about lately, girls, Anya and everybody else. Just a second ago, that square root wasn't on there. This is all stuff you didn't have to think about before, okay? So watch this, girls. Okay?
Flip it though, doesn't that make
I'm on the big secant squared graph, okay? I'm gonna choose to put the square root on it, so I'm gonna limit myself momentarily, but I'm gonna have to embellish it. So now I'm gonna square root and I have secant x is equal to the square root of 4 is 2 over the root 3. I'm not plus or minus. Good. So I'm gonna flip that and make that cosine x is plus or minus root 3 over 2. Girls, if I didn't recognize it, then I'd have to push inverse cosine and be really careful. If you push inverse sine, inverse cosine, or inverse tangent, you can talk to your calculator and go, thank you very much for the referencing. And now I gotta do some more depending on how it's worded. I know this one though, and it says plus or minus. I'm gonna pick all 4 quadrants at 30-degree angles. Did the back answer it in radians? Yeah, radians. So pi over 3, no, 30-degree angles. Pi over 6, 5 pi over 6, thank you, 7 pi over 6, and 11 pi over 6.
Wait, can we just go back for a second?
Uh-huh.
After we got plus or minus square root of 3 over 2, how do we get?
Those are 30-degree reference angles. You should
Oh,
know that
yeah,
from your memory
okay,
page.
got it.
So girls, the danger is, if I had cosine was like, cosine x equals 2/3, there is an angle where that happens. The only thing I can do is push inverse cosine. It's only gonna give me one answer. I've gotta make sure that I use my reference angle correctly. Any questions about 47?
Yeah. Wait, so it's just, oh, you're just naming all of them?
It's all of them, because it was plus or minus, so I gotta grab all 4
Oh.
quadrants. When you square
Got it.
root, you gotta say plus or minus.
Okay.
Dakota?
For that, when you square root, are you square rooting all of 4 over 3 or just 4 on that fraction?
The whole thing.
Okay.
That's why there's a square root on the bottom. I knew the top, the square root of 4 was 2, and the square root of 3 is the square root of 3. Great questions, girls. Okay, somebody said, would I do something next?
35.
35. All right, this is 35. All right, so 35.
It's 4 cosine squared x minus 1 equals 0.
Okay. 4 cosine squared x minus 1 equals 0. Let's look at our directions. On our directions, we're solving the equation, so we're finding everything. I don't know what the back of the book said. Did they give degrees or radians? Anybody write down the answer for 35?
35,
Yeah, the answer
agree.
was pi over 3 plus 2 pi n, and then 2 pi over
Okay,
3
thanks.
plus 2
That's
did
what I
not get
needed to
that.
know. Alright, it just said solve. It didn't say on 0 to 2
Yeah,
pi.
that's what
Mia,
the
what did you
max
get for
said.
35?
That's what I needed to know, thanks.
2 pi over 3, 5
So, Bren, I have cosine squared x equals 1/4.
Yeah.
I'm gonna square root, very similar to the last problem. That gives me cosine x equals plus or minus. The square root of 1 is 1, the square root of 4 is 2. I
Oh, that's where I
recognize
got
those,
stuck.
okay? Well, I know what
But
angle.
I figured yeah, I just messed up with the square root of 1.
Okay, so that answers that question. Those are 60-degree angles, which are pi over 3,
Mia's right.
2 pi over 3,
Oh, for some reason.
4 pi over 3. Girls, listen up. 5 pi over 3 plus 2 pi k, where k is any integer, because the period of cosine is 2 pi. That's not what Alex read me, so we're gonna talk about what else they may have said. What did you say? Or is that what they said?
No, they said pi over 3 and 2 pi over 3.
Plus what?
Plus the 2 pi over.
Did they have 2 pi?
2 pi k.
Can you?
Yeah, they wouldn't have done 2 pi.
Okay.
Hey girls,
Yeah.
I know that you might question, Ava, hang on, this is real important. Suppose that you're on multiple choice. Okay, we've been doing that for a long time. That keeps it going forever and ever by the period that it talks. We talked about birthdays and,
It's like
like,
the all
Oh,
real
were you out
integer.
then?
I was.
but still, we've done that day after day, once I taught it to you a long time ago. You need to make sure you keep up with the videos and stuff when you're absent. Because that's like a huge concept that I can't like recycle right now that they're used to, but, when's your birthday, Nazareth? October 18th, okay, so guess what, I know when your birthday's next year also. in 2020, 2021, I'll go, oh, it's Nazareth's birthday on October 18th. Every time I turn the calendar, now I know all of your birthdays. I know when your birthday was, back in 2015. It was October 18th.
Wow.
So these are all the times that it happens in one cycle. But doesn't it happen over and over and over again? These graphs go like this, always and forever. So when we say find the solutions and nobody says them 0 to 2 pi, they mean find all of the solutions in the whole wide world. And we do it with a pattern. So I need to move on, but we may want to meet about that, okay? Girls, those of you that know what 2 pi n or 2 pi k means, I don't care which variable you use, listen up. That is right. You could say that, okay? But also, look what somebody noticed. They could grab this one. Let me do it in green. This one's pi over 3. Look, 180 degrees later, you run into 4 pi over 3. So the back of the book said, well, we can shortcut this. We can go pi over 3 and 2 pi over 3 and just add pi k to it, and we'll catch them all as we're going. This one, if I add pi to it, doesn't it pick the, let's get purple and green. Sorry, that was kind of off, okay?
Oh, yeah.
If I take this one and add halfway pi, I pick up this one coming and going backwards and forwards.
2 pi, you'd go all the way.
And the
around.
purple one, no, the purple one, if I go halfway, I pick up this one as I go. If I say 2 pi over 3 plus pi, I get to 4 pi over 3.
Yeah.
And so this is a more concise, better way to write the answer. They're both right.
So you basically just write the 2 pi k when it says,
Find
0
all
to 2
real.
pi.
Yeah.
No, if it says 0 to 2 pi, I wouldn't write plus anything because it's just one rotation.
Oh,
You go 2 pi k and you start
just for it
flipping.
to keep.
It's like for all real.
Okay?
Okay.
But what's happening here, Ava, is there's a better way to write this problem. Okay? That one's right, but some of your exam's gonna be multiple choice. That's right. What if you look at that and go, oh my gosh, it's not in the multiple choice? Hopefully you would pick up that this is the exact same thing. All right, so once again, if I'm at red, if I'm at pi over 3, and I add pi to it, don't I pick that one up as I'm going?
Yeah.
Do you see what I mean?
Yeah.
Okay? So there's maybe a better way to write it that you might see in the multiple choice. So I just wanna make sure you're aware of that.
Yes.
Yes.
Do question 40.
There's nothing wrong with that one. That
Yeah.
one's fine.
Okay.
What number?
Did we do question 43 or 42?
We did 42. Do you wanna do 43?
Yes, please.
All right, this is 43. So, Nazareth, when you get better, just shoot me a email of when you can meet about the 2 pi k and 101.
I don't know, I made a habit to watch the videos for the classes that I have missed, but maybe I forgot.
Yeah, because you seem like the type that would. Maybe but at this point, let's just try to sit down together because you're so bright. You can just probably pick it up rather than sit and watch them for an hour. If you can't, then I'll find it and send it to you. But just when you're able and when you feel like it, when you have time, and you know that you're going to come by, let me know, or just happen by and see if I'm here. Okay. All right, girls. This is all in terms of secant, so I'm happy with this. So I'm going to go secant squared x minus secant x minus x minus secant x. That always happens once a year. All right, minus secant x minus 2 equals 0. That looks like that quadratic-y thing that I'm going to factor. I don't think quadratic-y is actually an adjective, but anyway, it looks like a quadratic. So I factor the front, and I factor the back, and I manipulate it until I get the correct middle. So this is secant x times secant x.
Those dogs are so cute.
Bless you.
And 2 and 1 minus plus. Great question. This gives me secant x is equal to 2 and secant x is equal to 1. I don't care about secant, so that would be cosine x is 1/2 and cosine x is 1. Cosine x is 1,
Isn't it
happens
-1?
right. -1, thank you, Brent. Okay, cosine x is -1, right, thank you, Brent. Right back here at pi. Okay, and cosine's 1/2 at pi over 3 and at 5 pi over 3. And these instructions, back to Nazareth's question, said 0 to 2 pi, so I found all the answers one time around. So I don't have to add anything to it to keep people going backwards and forwards for all the answers in the whole wide world. That's real sloppy. Pi over 3, 5 pi over 3, and pi. Question on that, Kate?
Yeah, so could you not just like factor out secant
No.
and solve?
No, good question. Sometimes you think your algebra teacher taught you to factor and set it equal to the number on the other side, but the number on the other side was always 0, and maybe you didn't notice it. Like if I have blank times blank equals 0. Well, here, I thought I had maybe done this with y'all before, but maybe I haven't. We're not going to play the game today. We're just going to talk about how the game would work. There are actually classes that I've said, if you can give me either one of those two numbers, I'll give you 100 major test grade.
Oh, that,
Do you remember
something like
that?
happened in our algebra, and Alexandra guessed it, and it was like
Yeah,
1, and
yeah.
she was like, you're like 100
Okay.
test grade.
Which I was trying to teach you not to do what you just asked, but you don't, it's, the light's gotta come on at some point, and most of y'all think that you could do what Kate is saying maybe, if you have secant squared x minus secant x equals 2, and then you factor this. You can't then set your factors both equal to 2. Girls, that only works with 0. It's called the zero product property. Okay? What happened that Anya remembers?
Have fun.
That's like 4 hours.
Chase for major.
I know.
Y'all squeeze.
Good luck.
Girls,
Yeah,
what
let's
Anya
go
might
fast.
remember is I had some 2 crazy big fraction numbers that multiplied to be 8. Did y'all see that there, I thought there was no way somebody would guess one of the 2 numbers, because I didn't do 4 times 2. I didn't do 16 times 1/2. I did I probably had square roots in it. It was some crazy number. Do y'all see, how many numbers are there that I could put in here to multiply to be 8?
Oh, just kidding.
A lot. There's
And
1 and 8.
There's an infinite amount of numbers. I don't think I could ever stop, okay?
Two.
I could go 64 times 1/8. I could go 1 over 64 times whatever 64 times 8 is. I could start with square roots. I could say square root of 8 times square root of 8 and get 8. I could have an infinite number. Girls, please watch, because I need the last 5 minutes just for me to talk. Listen up. If you factor, the reason your math teachers taught you to factor and set it equal to 0 is because I would not play the game with this. If I said, give me either one of these 2 numbers, what does one of them have to be?
0.
0. So your teacher said, well, either this one's 0 or this one's 0. If either one of those is 0, it works. Okay, do you see why you can't do this?
Yes.
All right, good question.
Also, even if you did that, you wouldn't get a number that like.
You
is-
wouldn't get the right
yeah.
answer, yeah.
So.
Okay, other questions on your homework. These are great.
Oh, I don't have one about homework.
Okay, let's stay with homework just for a second. Okay, all right, let me show you something real quickly. There's sometimes that people use something called U substitution. I didn't do that with y'all, I don't think at all, because I think that y'all are, I mean, I know you and I know your brain power and that you didn't really need this crutch. But I'm really stubborn. Okay, there are some people that go, oh, well, let's let secant x equal u. It's called u substitution, okay? Then that would be u squared minus u equals 2. And all of a sudden, students that haven't seen why I'm factoring, do you see it kind of makes it clearer for a minute?
Yeah.
So you can say u squared minus u minus 2 equals 0. And then you can factor and get u minus 2, u plus 1. Then you get u is equal to 2 and u is equal to negative 1. Are these people finished with the problem?
No.
What are you going to do at the end? You have to put u back in and keep going. Okay, the reason that I showed you that is because you'll have a few homework problems like this for homework.
Those are
What if
choose.
I have, they are, cosine 2x equals, let's say 2 cosine x equals 2 cosine 2x equals 1. And it'll say I want all the answers on 0 to 2 pi. Real quickly, with me looking at the time, I just changed the period of this graph. Did y'all see that?
Yeah.
What Nazareth is asking about what I added is gonna be different now, because the period of this one's not 2 pi, okay? So, all the time that I've been explaining the 2 pi thing to you, didn't your cosine graph just go like that forever? And you gotta capture all the answers. However, this graph is gonna go faster, and do you see there's gonna be more answers?
Wait, are we gonna know what happened?
Please watch, okay? Do you, all I'm asking is, okay, so Julia understands that, do y'all see what I mean?
Yeah.
If I double it, that just shrunk the
Oh, yeah,
period, like in your graphing, and there's gonna be more answers in there.
Yeah.
So, I think U substitution's a good way to go here. I'm gonna let U be 2x. So all you have to do is like old homework. 2 cosine U is 1. Cosine U is 1/2. And so the only difference is you gotta make sure you go around twice. I'll show you what I mean, okay? Y'all have done this for homework. What comes to mind is pi over 3. There's another one at 5 pi over 3. But this 2 is gonna make it spin around again. So how do I go around one more time?
Plus pi k?
Well, how are you gonna go all the way around from pi over 3?
Plus 2 is 6.
I'm gonna add 2 pi to it, okay? 2 pi is 6 pi over 3. So my next one is 7 pi over 3, and I'm gonna add 2 pi to this one, and I end up at 11 pi over 3. Okay? I'm not finished? No. I take U back out and put what back in? What was U?
2x.
2x, it was just a temporary fix. I did it all just with U, but I'm gonna go back and put in 2x. So now how are you gonna solve for x?
Divide by 2.
All of these we're gonna divide by 2. And I get pi over 6. Dividing by 2 is like multiplying by 1/2. Pi over 6, 5 pi over 6, 7 pi over 6. What's 11 pi over 6? Isn't that just right before 12
That's like
pi over 6?
300.
Do you see that just barely made it between 0 and 2 pi?
Yeah.
Okay, so what happened was I got 1, 2, 3, 4 answers by the time I got out to 2 pi. All right, so I tell you what. Dr. Dighton probably wants to get in here too because I don't have the last class today. I won't give you many of these, but I'll give you a few of them to try, or maybe not. I tell you what. Why don't we let the homework to go in and be exam review, and then in the next class I'll talk about this some more, so that you're not trying something brand new. But we probably will do some problems off the review that have to do with what I just did. Okay?
And I have a
So
question.
homework is memo quiz if I posted in assignments, and going to start reviewing.
And will we have questions like this with the U for like
Yes.
the circled questions, like the test part of the exam?